For the following function, state the equation of any vertical asymptotes in the ordered pairs describing the location of any holes. So we know to find vertical asymptotes and holes, we want to factor the function. And this is going to factor as x minus 3 times x minus 1 all over x plus 1 times x minus 1. And I know that my holes are going to occur where that common factor, and I would cancel that common factor, but I'd set the common factor equal to 0 and I'd get x equals 1. To find the y-coordinate of that hole, I would just substitute the 1 into the remaining factors. So that would be 1, your y value would equal 1 minus 3 over 1 plus 1, which would be negative 2 over 2, which would be negative 1. So the hole is located at 1, negative 1, and we'll check this later on our calculator. The vertical asymptote you find by setting the remaining factor in the denominator equal to 0. So your vertical asymptote is going to be when x plus 1 is equal to 0 or x equals negative 1. That's the equation of your vertical asymptote. Now to use limit notation to confirm that that is a vertical asymptote, in other words, algebra told us that to find vertical asymptotes we would just set the denominator equal to 0. Calculus gives us a way to describe them using limits, and so that's what I'm asking you to do here. And so what I want to do, I know that asymptote exists at x equals negative 1, so let's find the limit as x approaches negative 1 of f of x. Well, this is the limit as x approaches negative 1 of x minus 3 over x plus 1. Since the x minus 1's cancel, the limit's going to be the same with those factors or without them in there. From here we'll set up a sign chart. We know that the numerator equals 0 when x equals 3. The denominator equals 0 when x equals negative 1. I care about what's happening to the left and the right of negative 1. So I'll pick a test point to the left of negative 1, say negative 2, to the right of negative 1 and between negative 1 and 3, which would be 0. It's just one possible. When I substitute negative 2 into the function, I get a negative in the numerator and a negative in the denominator, so that will give me a positive. And when I substitute 0 in, I get a negative in the numerator and a positive in the denominator, so I'll get a negative. And so the limit as x approaches negative 1 from the left is going to be positive infinity, and the limit as x approaches negative 1 from the right is negative infinity. And so this is basically describes an asymptote, a vertical asymptote. If x approaches a finite value, if as x approaches a finite value, the function grows without bound, either in a positive or a negative direction, you have a vertical asymptote. So let's just confirm this on our calculator. We'll put the original function in for y1, x squared minus 4x plus 3 in parentheses, then divide by the denominator also in parentheses, x squared minus 1, close the parentheses. I'll do a zoom 6 since my asymptotes really happen between negative 10 and 10. Alright, so we said that we found that there was a vertical asymptote at x equals negative 1. If I trace on negative 1, you can see that we don't get a function value because it doesn't exist, and you can look here at the value of negative 1. You can see the calculator is confirming what we suspected, or what we basically confirmed analytically the calculator is showing. And as far as testing the hole at x equals 1, if we traced on 1 and hit enter, now we can see there's not a vertical asymptote there, but we do see that when we trace 1 there is no value. The function is not defined there. And so the calculator kind of confirms our analytical work. So sometimes we do analytical work and we check it on the calculator. Sometimes we make a conjecture using the calculator and we use our analytical work to confirm that. Just remember that you're not always going to have a calculator. There will be times that you'll be given a problem like this on a test where you won't have a calculator to check. So you have to be confident in your analytical work. At this point, I'd like you to try to create your own function that has a vertical asymptote at x equals 4 and a hole at x equals 3. There's more than one answer. There's actually an infinite number of functions that would have this, but specific things have to occur in order to have that vertical asymptote at 4 and a hole at 3. And I would like you to also state the ordered pair of the hole for your function. Start the video once you have come up with your function, and don't start it too soon. Give yourself a chance to actually, to try this. Fight through it a little bit. Alright, I'm going to take you through my thought process when I'm trying to figure this out. And so what I know is I'm going to come up with a rational function. I know that in order to have a hole at x equals 3, that I have to have a common factor in the numerator and the denominator of x minus 3. So that's going to take care of my hole. In order to have a vertical asymptote, I'm going to have a factor left over after reducing, a factor of x minus 4. That would give me a vertical asymptote of x equals 4. And so I'll put my factor of x minus 4 in the denominator, and then in the numerator you can put any factor you want, any binomial factor or a monomial. I'll put in an x, right? And then I'll simplify my function. So my function is going to be f of x equals x squared minus 3x all over x squared minus 7x plus 12. Your function may be completely different from mine. Again, you could have any factor in the numerator would work. And you can also graph yours on a calculator to confirm. And to find the ordered pair of that hole, you know that x minus 3 is going to cancel. So if I substitute 3 in for x at this point, so my y value is going to be 3 over 3 minus 4, which would be 3 over negative 1 or negative 3. So my hole would be at 3, negative 3. And let's confirm that on the calculator. So I have entered the function x squared minus 3x divided by x squared minus 7x plus 12 in my y equals. I'm going to graph it. I'm looking for a vertical asymptote at x equals 4 and a hole at x equals 3. And I can see at 4 it certainly appears that there is a vertical asymptote here. I'll trace 4 to see that no y value will show up. That's good. I also want to confirm that at x equals 3 there is a hole, so I'm going to trace on 3. And so the function is not defined at 3, but we came up with the ordered pair that represented that hole, 3, negative 3, by substituting that 3 back into the simplified version of the function. Alright, I hope you did well on that. And if you're unsure if the function that you came up is correct, then just check with me in class, or you can also send it to me in an email and I can confirm that for you.